Kumar. Today I'm going to teach photoelectric effect. To understand photoelectric effect, we have to know first the nature of light. In photoelectric effect, what we are doing is we're taking a metal surface. In photoelectric effect, what we do, we okay. Yeah, in photoelectric effect, what we do, we take a metal slab, and metal slab have many electrons inside it. And when light fall on the metal, it eject electron or it emits electron. When the light fall on any metal surface with a specific frequency, so with a suitable frequency, then metal emits electrons. So how this phenomena is occurring? In photoelectric effect, we understand how metal ejecting electron from its surface on falling of suitable frequency of light. So to understand, we need to see first dual nature of light. In dual nature of light, we have two nature. One is wave nature, and one is particle nature. In wave nature, we have seen the reflection. Uh, we have seen refraction, and diffraction. In particle nature, in particle nature we know the particle will have momentum and the kinetic energy. So in photoelectric effect, we use here particle nature of light. In photoelectric effect, we use particle nature of light, and due to its momentum and kinetic energy, collide with when light collide with electrons, it transfer its kinetic energy and momentum to these electron, and then with this kinetic energy, the energy gained by this electron due to uh, collision with photons, it gains some kinetic energy and start moving. With this kinetic energy, this electron comes out of the surface of the metals. So to let's first see how much energy a photon have and how much momentum it's have. And another function, what's the basic requirement to eject electron, that's the work function. The photon, let's see first photon is a like particle of light. It travel with a speed of light, and it possesses both energy and momentum. So uh, yeah, it possesses both energy and momentum. So how much energy it, if a light is coming out with of f frequency, if the frequency of light is f, this is frequency frequency, then the energy of photon will be h into its frequency, and the momentum momentum of photon will be h upon lambda. So even this energy, we can write in this way as well. H frequency we can write like c upon lambda, and h and c is a constant, and on calculating it we will get upon lambda in nanometer. We have to put this value in nanometer, and we will get energy in electron volt. So the another concept is work function. What is work function? To understand work function, like let's see, we have a metal surface that has many electrons inside it. These are the electrons inside it, and when light is falling on this metal surface, then electron getting emitted. The electron getting emitted. So The work function is defined we define as the minimum energy of the photon, minimum energy of photon required to emit these electron. Minimum energy, what we define is minimum energy of required to remove electron from the metal surface. So, like if the energy of photon, whatever photon falling on the metal surface, if it is greater than or equal to work function, then only we will get emission of electron. Emission of electron will occur. Emission of electron will occur. If this condition satisfied, then only emission will occur, otherwise emission will not occur. So let's see, the next thing is, um, if if the condition is satisfied, if the condition is satisfied that energy energy of photon falling is hf is greater than phi, then emission will occur. Emission will occur. Emission will occur. Will occur. But what what the value of kinetic energy? Kinetic energy. So kinetic energy of electron can be in the range of, it's in range of kinetic energy of electron in kinetic energy maximum. It can have maximum, that is energy of photon minus phi. So we can write hf minus phi, where f is frequency of light. F is frequency of f is frequency of light. F is frequency of light. So why it's having in the range? Because we can see here there are many electrons here. There are many electrons. Even like this photon is tracking this electron. Before coming out, it can even collides with any other electron, or it can collide with many times, and it can lose all of its energy due to collision with another electron. So due to its collision, even it's losing its energy at the time of when the photon collides with this electron. The energy that this electron gain is electron of energy of photon minus phi, but due to collision it's loses its most of the energy. Most of the time it's loses, and it can have maximum. If without any collision, if it is coming, then it will have kinetic energy maximum. If it's collided with some any other electron, then it loses some of the energy. So it can have in the range of, its kinetic energy will be in the range of this kinetic energy E minus kinetic energy, where kinetic energy maximum be defined as like hf minus phi. Hf minus phi. Okay. Then now let's see the experimental set of how the photoelectric effect is occurring. So in photoelectric effect, what we have is a metal surface and a complete circuit. What we do, a bit of frequency of wave, frequency frequency of if frequency light. This is frequency. And one more thing, that uh, the condition should satisfy, like if energy h mu h if should greater than or equal to 5, then only electrons will come out from this metal surface. Electrons will come out from this metal surface On as the light will incident on it, the electrons will come out of the metal surface, and some at the initially I'm taking here two case, condition 1 and condition 2, where in condition 1 I'm taking potential applied is equal to 0. So when potential applied equal to 0, even that time some of the only few electrons will reach from here to this plate and produce some current in the circuit, and we will see current inside the circuit, or in ammeter we will observe current. It will not equal to 0, it will be having some of the current. So in condition to what we are doing, be increasing potential. So let's see. In condition to be increasing potential, as potential get increases, it's a positive and it's a negative. So here even it will be positive, and electron is negative, so electron will get attracted to this positive plate. As the potential increases, the attractive force on the electron is increases, and it's most of the electron get attracted to this plate. Most of the electron emitted from the metal surface due to the light get attracted to this plate, and then as be increasing potential, the current in the circuit gets increases. So we can see here at the zero potential even we have some current. In condition 1 we have seen this. In condition 1 we have seen this, at even zero potential we have some current, and condition 2 as we increasing the potential, current is increasing. But after a certain time its current will be saturated. The region of saturation of current is, we can, after certain time current will be saturated, and this saturation we can see in the next slide, or we can understand here. Saturation is occurring because the emitted number of electron is fixed. These electrons these electrons are fixed number of electrons are emitted, fixed number of electrons emitted, fixed number of electrons getting emitted. So a time will come of, like, as we increase the potential, most of the electron will attracted to this plate, and a time will come when all the electrons attracted from here to and come to this plate, and maximum current that we can get is, that will happen, like a time will come on increasing potential, maximum electron that is present there, that came out from the metal surface, will participate in the current flow, and due to that, saturation of current will occur. To increase this current, what we can do, we can increase the intensity of the light. We cannot change the saturation current by increasing potential. We can just what we can do is, we cannot change saturation current by increasing potential. We can change saturation current by changing the intensity of light. So we can see here what the definition of two things. Saturation current, it's a maximum current that can be produced when a metal surface is exposed to a certain frequency of light. We can see here, like in this diagram. In this diagram, we can see here, as we are increasing intensity, like current current is increasing, saturation current is increasing. This is saturation current getting increasing on increasing the intensity. Phi on increasing intensity, saturation current is increasing. We can see, because intensity is proportional to number of photons falling. Number of photons. So as the number of photon increases, intensity of as the number of photon increases, the electron emission electron emission increases, and number of electron emission increases means current is getting increased. So this is the reason why the saturation current increasing on increasing intensity of the light. The second thing is a stopping potential. A stopping potential is potential at which no electrons are able to leave the metal surface. Means at that time the current will be I will be zero in the circuit. We wanted to make this I zero in the circuit. It represents the maximum kinetic energy of the electrons, emitted electron. So we have seen here, we have seen here in the kinetic energy that kinetic energy of the electron is in the range of 0 to kinetic energy maximum, and the maximum electron with maximum kinetic energy, if we is able to stop that electron, we can stop other all electrons. So being how much potential we need to provide to stop that electron is how much potential we need to provide to stop that electron. Oh, sorry. So to stop that electron, we need stopping potential E into V naught is equal to kinetic energy maximum, and we know kinetic energy maximum is E of photon minus phi. So from here we can calculate the V naught 1 upon E into E H into F minus phi. So this is a stopping potential that stop even the maximum kinetic energy